Okay, thank you, Steve. How's my voice? Can you hear me okay? Are we levels okay for everything? Okay, good. Because it's a large room and I can't really tell from standing here. I want to thank Steve and the members of the organizing committee and the university for the invitation to come here and join you for Darwin Day, which you've been doing for a number of years now. I've had the opportunity to visit with some classes and meet various people around campus in the last few days when I've been here. I've had a very enjoyable time, and I hope for your sake that when I leave tomorrow morning the weather doesn't go back to usual for you. It's been really pleasant for me here in the time that I've been here. Okay, so what I want to do, some of you I know were at the talk yesterday which dealt with more with the work that we do at National Center for Science Education in terms of supporting the teaching of evolution and opposing the introduction of creationism into public school biology classes. Tonight I'm going to talk about something different, more to do with the history of studies of human evolution, the human fossil record in particular. And because it's Darwin Day and we're celebrating Darwin and his accomplishments and so forth, to sort of tie these things together, we're going to go, we have to go toggle to the other screen. And it's disappeared here, so I don't know. Yeah, sorry. It's disappeared off the monitor, so I don't know what you, okay, well that was hard. Whoop.
It's coming back.
Okay.
Yes, there.
Yes, there we are. Thank you. Okay.
If you could just project a little bit more on, let me move this up just a touch. That may help. You still good in the back?
Okay, how's that? Is that okay? Is that okay for you? Okay, thanks very much. Okay, Darwin and the Human Fossil Record. I made up this title before making up the talk, and a while ago when I did it. 150 years of discovery, exploration, and debate, and then I started thinking about that, but I'd already sent the title to Steve, and 150 years, and we have 50 minutes, so that's 3 years a minute that I have to get through in terms of the human fossil record, and if I were to be teaching a class on the human fossil record and its the history and so forth, I would have to be covering, every 20 seconds I have to get through a year's discoveries. And so maybe that's a little too ambitious in terms of 3 things that we're going to cover. So we're not going to actually cover all that stuff in detail, obviously. It's in 3s because 3 is the magic number, and it sounds better if you do things in 3s. But I am going to talk about Darwin and his views and thoughts on human evolution, and the fossil record, specifically about the fossil record. And I encourage those of you who can to come tomorrow night. It's tomorrow night. The film presentation that you'll see is a very good film. I've seen it before by Dr. Tim White, who's a professor at Berkeley, which will show you, I am not going to show a single picture of a fossil tonight, but he will show you lots of fossils and lots of field work and the way that people conduct research today, modern techniques of doing research and all the different sciences that cooperate and work together to extract all kinds of information about the fossil record. So that's an opportunity to see and hear more about the nitty-gritty of what's going on right now in fossil work. And what I'm going to be talking about today is more about the history and the development of some ideas about human evolution and the fossil record. So we should start with a joke. First thing I should say, actually, before I show the joke, is that, okay, so Darwin and the human fossil record. Darwin actually wrote in books or publications or whatever, how much did he actually write about the fossil record, the human fossil record? He actually wrote essentially nothing about the human fossil record. So I guess we're done now and we can all go home. No, but that's partly because there basically was no human fossil record at the time that Darwin was writing and working. There were a few discoveries that had been made, but very, very few. So just as a preface to this, various people, all kinds of people, have lots of different opinions about human evolution, and because it's human evolution, we're all interested in humans, we're all interested in ourselves. It's a topic that is very, very popular in the public in general. Where did we come from? What's the meaning of our existence? What's the purpose of life? Some of these are not scientific questions. They're not anthropological questions, but they're interesting and important questions. So I just have a couple of examples of alternative views that one might have about the meaning and purpose of human existence. And I'm not sure how many of you can read these from the back, but Calvin says, just think, Earth was a cloud of dust 4.5 billion years ago. 3 billion years ago, the first bacteria appeared. Then came sea life, dinosaurs, birds, mammals, and finally, 1 million years ago, it's actually more like 4 million years ago, but that's okay, man. Now, in 1988, there's me, the acme of evolution. And Hobbes says, oh, please. Okay? So this is one attitude towards the significance and meaning of human evolution. There are, however, alternatives. As, for example, I wonder why man was put on Earth. What's our purpose? Why are we here? And Hobbes' answer is tiger food. Okay? So the significance and meaning of human evolution may vary depending on the viewpoint with which you start things. Okay. Now the actual talk. I'm going to talk a little bit about each of these points today. Human evolution without a fossil record, since that's what Darwin was really talking about and dealing with when he did confront and discuss things to do with human evolution, was what can you tell about human evolution? What kinds of ideas can you come up with without a fossil record? Darwin's model of human evolution, and where are we now in terms of thoughts about some of these things. So the things that I'll first tell you what Darwin did say directly about the human fossil record. In The Origin of Species, of course, from 1859, his major work on putting out the concept of evolution, bringing it to the public. The only thing he says about humans in this context in the whole book is a very short line: light will be thrown on the origin of man and on his history. That's it, okay? He had, of course, been working on and collecting information and ideas and notebooks on the subject for decades at this point, but the book was already so big, he knew that just talking about the concepts of evolution and the idea that species were related to each other and not separately created was going to be controversial enough, okay, just to get those ideas out into the public. And to take on humans at the same time was just more than he really wanted to do. He wanted to sort of prepare the ground, and then later he would take the material that he'd been collecting about humans and put it out as a separate publication, which he did in 1871, the book The Descent of Man, which actually covers several topics. But so The Descent of Man is all about human evolution and ideas about possibilities for human evolution. So in this book, he summarizes his data and his thoughts about human evolution. The only thing that he says directly about fossils, however, in the book is one passing mention on one page about Neanderthals, sort of what we now view as very close human relatives. But at the time, the very first Neanderthal fossil had only been discovered in Germany in 1856. And so that was only 3 years before the Origin of Species book was published. And then The Descent of Man didn't come out till 1871. By 1871, there had been several publications on the first Neanderthal fossil, some in German, some in English. There was information out there. It was a well-known specimen, but it was essentially the only ancient human-like fossil that had ever been found. Right? So he had a sample n equals 1. And he said about it, basically, he was talking about how human ancestors might have probably had smaller brains than people do today. And then as a sort of sidelight, he says, but interestingly enough, the famous Neanderthal specimen has a large brain, same size as modern humans today. Goes on, talks about other stuff. Nothing more directly about fossils per se. However, in the rest of the book, he discusses a number of topics, and for our purposes, the main one is human evolution. The purpose of the book, he puts out explicitly, why did I write this book? What is it about? The purpose is to ask, are humans, quote, like every other species, unquote, descended from some pre-existing form? Are humans related to other organisms by what he called descent with modification? Did we share common ancestry with other species? Or were they, so he wants to demonstrate that this is true and that humans were not separately created just as the way they are now at some point in the past. So if the answer to the first question is yes, and he had determined that in his own mind the answer was yes, if it's yes, then how has our species, Homo sapiens, developed over time? If our ancestors in the past were different than we are today, how were they different, and how did we get to be the way we are now? And third, what is the meaning of the variation that you can see among what he calls, quote again, so-called races among people today? That part I'm not going to talk about because that's a separate topic, but that is something else that he dealt with in the book, is variation among modern human populations around the world. So there were two fundamental principles, two fundamental premises which Darwin accepted from the work of other people that were allowed him to go ahead and talk about human evolution through time. So he accepts, first of all, that from the record of archaeology, which was developing as a science at the time, not from fossils, because there weren't any fossils except the one, as I just said, but he accepts that humans have a high antiquity. As a species, as a group, we're old, geologically old, okay? Not just a few hundred years, obviously, from history, not just a few thousand years, but from the evidence of archaeology, which at that point, the kinds of things he's talking about is, if you went out in Europe and went to the right places, you could find archaeological sites which contained stone tools in them, which were simple, primitive, chipped kinds of things, like nothing that people living today anywhere in the world made. But that occurred in high frequencies and in patterns that suggested that something that people or something like people had been making them in the past and had been living with extinct animals, because the bones of the fossil animals were found, unlike anything that were found today, elephants living in Europe and things like that. And these were looking at the geology, the sediments, the structure, and so forth. It was clear that these rocks, that these archaeological sites and the fossil animals were being found in were very ancient, many, many, many thousands of years, many, perhaps millions of years old. He didn't know exactly. Geology didn't have the tools in those days to put precise dates on these things, but the relative order and sequence of things could be worked out for a lot of things. So it was already, geologists had been busily at work for more than 50 years at this point, developing geology, and the general consensus among was that the fossil record of human ancestors suggested they'd been around for a long time based on the stone tools. So that's number one. Humans have been around for a long time, or things like humans, enough like humans to make stone tools anyway, which nothing else that's alive today does. And two, the second fundamental premise was that humans are relatively, of all the organisms you can compare us to, of all the things that are alive today, are close to apes. If you were going to pick out what kinds of animals, what kind of organisms are humans most similar to, most like, most closely related to, it would be apes in particular, like the chimpanzees and gorillas and orangutans, all of which were known at the time, although gorillas had in fact only been come to the attention of Europeans a few years before Darwin was writing again. Chimpanzees and orangutans had been known for hundreds of years to people in Europe who had written about them. People in Africa knew about gorillas, of course, but the people in Europe didn't. Okay, so, but in particular, apes like chimpanzees and orangutans were much more like humans than monkeys were, for instance. If you compare monkey and ape, monkey and human, ape and human, apes and humans are pretty similar compared to the monkeys, which are quite different from both apes and monkeys. So he says, if I'm going to think about human evolution and what we might be closely related to, I'm going to use apes as the organisms I want to think about, and I'll use monkeys a little bit and maybe some other creatures as well. He used a comparative method of looking at the anatomy and the behavior and the social structure and as many kinds of characteristics and sources of data as he could find. But he wanted to look at things that were most like us as being the most informative about the kinds of questions that he wanted to ask. So, despite the lack of fossils, he says, it's possible to, or we can say today, it's possible to propose some sort of general scenarios or general ideas about what might have happened in human evolution. So how do you do that? How is it possible? Some people think, I mean, it is really nice to have fossils, and fossils are useful in lots of ways, but one can actually, for many organisms, one can look at them and compare them today to their close relatives and draw some conclusions about what might have at least happened in the past based on just on living organisms without a fossil record. So how can we do that? So this is what Darwin did as a sort of thought experiment, and we can do the same thing tonight here. You can all be Charles Darwin, virtual Charles Darwins in terms of doing all this. So what you need to do is to think about what sorts of human characteristics, attributes, behaviors, anatomies, what is it about humans that makes us different from other organisms? What are the things about us that are unusual compared to what you normally see in other organisms? What's unique about us? What are human characteristics compared to our relatives, especially compared to primates and animals like apes, chimpanzees, orangutans, gorillas? What is it that makes us different? Class, suggestions? It's going to be an interactive session here. Do we have a problem with the sound?
No, thumb.
Oh, thumb. Okay, sorry. What about the thumb?
It's opposable.
It's opposable, yeah. All kinds of primates have thumbs, right? Having 5 digits on your hand, this is a really ancient characteristic. Many, many animals do. But the proportions in the fingers in human hands and the fact that the thumb is relatively large, opposable to the other digits, capable of manipulation, okay, that's a good one. What else? Yeah.
Aren't we the only species that can cry?
He says,
Also, that can express emotion.
yeah. I'm going to repeat what people say. I just realized I remembered I have to do it for the purposes of the camera. So he says, aren't we the only creatures that cry or express emotions? Verbally, okay. I don't know. You ever had a dog get whipped or, and respond to, I mean, I'm not sure. Nobody's ever suggested that before when I do this exercise. So I'm trying to think on my feet. You can see the emotions. Okay, so maybe specifically crying as a response. Well, verbally.
And being able to understand it.
Okay. Verbal's a really good word in there. Using language broadly, broadening your thing out to language and communication, but not just communication, because lots of creatures can communicate with each other, but the sort of spoken verbal language that we can do, right? That I can stand up here and talk about things that happened 150 years ago, and I don't have to show you any pictures, and I don't have, and you can form in your mind some pictures which I hope are relatively similar to what I have in my mind when I'm talking about it and get that across. Yeah. Okay, cognitive development, she says. Okay, meaning?
Like self-awareness, ability to rationalize.
Okay, being self-aware and rational. Boy, wouldn't it be nice if we were rational? I mean, that's something that people often come up with, and the capability for rationality certainly is there sometimes. So it may not be permanently expressed at all times, but yes, I take your point. What else have we got? Yeah. Large frontal lobes and goal-oriented behavior. A lot of animals have goal-oriented behaviors, I think, if you just look at what they're doing. Planning for the future. Let's see, if I take my nuts and I bury them here and then I come back in the wintertime, will I be able to find them? Yeah. Is that instinctual in that case? Okay, well, I'm not going to, semantics aren't important, but I take large brain and the relationship of a large brain, which is related to what she just said about cognitive sorts of things. Certainly the degree to which we have these capabilities, we're not unique in it, but the expression of them is certainly maybe order of magnitude different than what you might see somewhere else. So what else? Yeah.
Got one more.
Yeah.
How about just having a knowledge that right now we're pushing up daisies, or stepping on daisies, and eventually we know that we'll be pushing them up and no other species does that.
Okay, having the awareness of death, basically. It's a little hard to know what's going on in the minds of other animals, but certainly you could make a case for that, I think. Yeah.
I guess the ability to create like a written history.
Ability to create written history, writing related to language, related to large brain size. Certainly you don't find writing in other organisms. Yeah.
Artistic expression or ceremonial behavior?
Artistic and ceremonial sorts of behaviors. I'll just expand that out into culture in an anthropological sense, which includes that and all kinds of other things, okay? But the elaborate degree to which our social groups interact and communicate. Now, a lot of these kinds of things, was there anybody else before? Yeah.
Are we the only bipeds, like walk on our feet?
Are we the only bipeds? Thank you very much. Standing the way I am up here and walking around the way I am up here, okay? Walking on 2 feet. Now, of course, there are lots of birds around that walk around on 2 feet, but they don't do it the way we do it. No other creature that is bipedal, habitually walking on 2 feet, does it in the way that humans do, balancing on those 2 feet with no tail, with the spine erect, not bent over and sort of counterbalancing things back and forth, and birds with tails and wings and all that kind of stuff. Okay, so being bipedal in the fashion that we do is definitely another one of these. Let's see, what do we not have on the list that needs to be mentioned? Oh, that's a good one, and that's a good one. Okay, any more? Because we got some big ones that still haven't been mentioned. Yeah?
Young have a comparatively long childhood.
A comparatively long childbirth. That's a matter. Pardon me? Childhood, okay. Yes, that's true. There are a lot of primates, it's also relatively long. It's somewhat longer in humans. So it's different, but that's not a dramatic difference in terms of a uniqueness, but it is at a further degree. Who's going to help me out with, yeah? Okay, the way in which we get our food, agriculture and domestication and of other creatures, and is certainly on a different level than what you would find in other sorts of things. Yeah?
Hair is different.
Our hair is different how?
Are you sort of like covered everywhere, or we just have like...
Our hair has a different kind of body distribution than you would normally find. Actually, if you count up, it's interesting, if you count up the number of hairs per square centimeter or whatever on arms and legs and things in humans, it's not particularly different from other apes. It's not the number of hairs, but they're fine. Okay, you don't have the long, coarse hair all over the body. It's restricted to certain areas on the body and not everywhere. So we've certainly changed the pattern and distribution of hair compared to primates in general for some reason. Okay, so yeah.
The creation and use of complex tools.
Creation and use of complex tools, right, is another good one. Okay, so these are all the kinds of things that when I ask an audience to come up with things that everybody knows, things that people are different, ways in which people are different from other animals. And many of these, of course, are obviously all related to each other, right, in various ways. The language, the size of the brain, the knowledge about death, the social status and communication, and the making and using tools and complex tools, which sort of technology on a high level of use. Okay, 2 things that nobody mentioned that are significant in terms of what we'll talk about tonight. One is maybe so ubiquitous and important, but not really present in our lives so much, and that's controlled use of fire. Okay, we don't depend today, certainly people around here and in this country, we don't depend on fire every day directly to cook our food and make our pottery and scare away our predators and so forth. You turn on the light switch if you want to have light at night. You don't have to light a fire. But the controlled use of fire as a sort of aspect of technology is so fundamental to the development of all kinds of other technologies that came later, like metal use and metalworking and so forth, depends on having fire, pottery, all kinds of things like that. So the ability to control and use fire was extremely important when it happened and laid the groundwork, even though it may have been hundreds of thousands of years later, for other things. And the one other thing I'll mention that is significantly different about us in terms of anatomy is in terms of our jaws and teeth and face and the structure and proportions there, so that our jaws and faces are flat and our teeth are small and our jaws are small. And among all of our relatives, if you look at the size of the jaws and teeth compared to the size of their bodies, obviously body size is related to this as well, but they have large jaws, they project forward, the faces project, the teeth are large, variably large, different teeth, but especially the canine teeth, especially in males, is a lot bigger than in females in many primates. And this is the kind of thing, when you get to jaws and teeth and anatomy like that, that's the kind of thing you can start actually seeing in the fossil record once you have fossils. So, okay, and these kinds of characteristics people have known about forever, and it's not a secret or whatever that these are all things that are unusual about us. And so if you're interested in the idea of human evolution, or even if you're not interested in evolution per se, but if you're just interested in where did we come from and how did we get to be the way we are, explaining these kinds of characteristics is something that you need to do, okay? Are there, was it for this reason or that reason? Was it chance? Whatever it might have been, these are all characteristics, although many of them are interconnected in various ways, you still need to try to explain them. So, however, given that this set of things, and you could come up with others probably, but given that these sorts of things are either truly unique or essentially unique and very unusual in us and are not found in chimpanzees or orangutans or gorillas or other primates, and given from Darwin's perspective, the point he starts with, that humans have descended from common ancestors with apes. If you went back to that common ancestor, and he didn't know how long ago it was, could have been 100,000 years, it could have been 1 million years, it could have been 10 million years. He didn't know in absolute years, but he knew it was a long, long time ago, and a long, long time before recorded history started. If you could go back and look at that common ancestor whose descendants, some of whom became apes, and some of whom eventually became us, what would that common ancestor have looked like? How would they have behaved? Okay, and so it's really just a logical sort of thought that if you're going to propose, this doesn't prove anything, but if you're going to say, well, what would I expect if I could somehow test this? What I would expect is that common ancestor would have been probably like the apes in all those things and not like us, because we're unusual in these things. There are plenty of other things we share with the apes, and so those don't help us to distinguish. But the changes in those kinds of characteristics have taken place in the human lineage sometime in the past. So that the common ancestor probably, almost certainly, certainly, did not have language, did not make stone tools in a complex kind of pattern, did not have culture in the human kind of sense, did not control fire, was not bipedal, did not have a hand like ours with an opposable thumb, did not have a large brain, but had a brain the relative size of apes, all right? Did not have reduced hair, but had a pattern like you see in other primates, did not have small jaws and teeth, but had relatively large jaws and teeth. Okay, so we can say this is a proposal for what the common ancestor might have been like. And now there's a way to test that, a way that would be possible to test that, and which has been done for the 150 years since then, is to, if you start finding fossils, to look for the characteristics that leave a trace in the fossil record, like jaw and tooth size, brain size, actually the technology, which archaeological record is wonderful, stone tools. Once people started, people-like things, started making stone tools last forever. And you drop them on the landscape, you throw them away. They're not going anywhere. I mean, they may wash around, but they're not breaking down. They're not being degraded. Once somebody started making stone tools to a regular pattern in a regular way and dropping them around in the landscape, you can be pretty sure that, yes, that's exactly what they were doing, even though we don't have the bones of the individuals themselves. What you can't tell from the fossil record when you start to test these kinds of questions is how and when did the changes take place, okay? Did they all happen at once? Was it possible that there was this thing that was completely primitive, ancestral, and then it sort of all changed at once into this thing that's more like us? Or did things happen in a sequence at different times? It turns out the answer is they happened at different times. But which came first, and second, and third, and fourth, and fifth? What are the really ancient changes, the ones that sort of start us off? If you wanted to think of it as a sort of road to modern humans, that's a terrible way to think of it because that implies progression and teleology, and well, it's a philosophically terrible way to look at it, I think. But anyway, something came first, and then something else, something else, something else, and how are these things related to each other, in what order did they come? You can't tell that from the present. You can only tell that by looking at the fossils. You need the fossils to get a fossil record to get those kinds of details, and that's what people have been doing for the last 150 years, is trying to fill in that kind of evidence without having any fossils. I mean, by having fossils and to fill things in. Okay, so that's how you can do this kind of thing. So now what specifically did Darwin suggest as a model for how human evolution might have taken place? He didn't say the way it happened, but he said, okay, let's think about it and what might have happened. So he used evidence from comparative anatomy, from embryology, okay, from behavior of organisms, whatever he could find. So he starts off by saying, okay, humans are clearly primates. This had been clearly well accepted in sort of scientific community for more than 100 years by Darwin's time. Linnaeus in the 18th century classified humans among the primates and are most closely like monkeys and apes, the ones that he knew at that time. Everybody knew humans were very close, very clearly primates if you're going to classify them as anything. And within the primates, we're most like what are called Old World monkeys and apes, and especially the apes, what were called in Darwin's days the anthropomorphous apes, which just means shaped like humans, which is chimpanzees, gorillas, orangutans. Okay, so Darwin says our close relatives, close ancestors would have been sort of like chimps and gorillas if you had to pick something that was alive. And the two biggest changes in humans, as far as Darwin concerned, was the brain, the size of the brain, and the capabilities that apparently come with increasing size of the brain, cognition, language, stuff like that, and erect posture, okay? Standing erect, walking the way we do, not on all fours in any of the fashions that apes do. Okay. Then Darwin says, since usually if you look at living mammals around the world, the living mammals that live in any particular region are related to the extinct ones in the same region. This was known from fossils that have been found in various places, not of humans, but of all kinds of other animals. And in fact, on Darwin's famous trip around the world, the Voyage of the Beagle, he collected fossils in South America. He collected all kinds of things, but he did collect quite a few fossils in South America of fossil mammals, and they were, once they were studied and looked at, found to be similar to living mammals that lived in South America today, related to armadillos and various things like that. They were not related to African mammals or European ones, but specifically to South American ones. So he had some direct experience with that. Mammals today tend to live in the same region as extinct mammals that are similar to them or related to them. So therefore, he says, it's most likely that the ancestors of chimpanzees and gorillas, which live in Africa today, would also have been living in Africa. Okay? And since humans are most close to chimps and gorillas, of all the animals we can compare them to, it is, and direct quote, somewhat more probable that our early progenitors lived on the African continent than elsewhere. He says somewhat. He doesn't say this is definitely the case or it's definitely true, but it's more likely, somewhat more likely to have been in Africa than somewhere else. This at the time was a really, unusual thought to put forward. Even for many decades after Darwin, people had lots of speculations and thoughts about if humans originated somewhere, where did they originate in the world, right? Pretty much nobody's ever thought that humans originated everywhere in the world at once. Everybody pretty much has thought that they originated somewhere and then spread to other places. And among Europeans, at least, suggesting that it was in Africa was not a really common thing to do in the middle of the 19th century. Okay, so what would the early progenitors of man have looked like? What would they have been like? What were the ancestors of the human lineage before they separated from the apes like? And these are all direct quotes from what Darwin says in The Descent of Man. They were no doubt once covered with hair. Their ears were pointed and movable. They had a tail. Nobody mentioned tails here. Of course, that's not unique to us because of chimps and gorillas, but the foot was prehensile, that is, grasping, not like ours. This is related to being bipedal, of course, where we have a big toe in line with the others, and you don't have a gap between the toes, and it's well adapted to supporting weight and posture and so forth, in contrast with even chimps and gorillas, which have a foot that looks much more like a hand to us because the first toe is shorter and more separated from the others and able to grasp and hold on with their feet, which we can't do well at all. Okay, these early progenitors would have been arboreal, that is, living in trees, the way our primate relatives do. They would have lived in a warm, forest-clad land in the tropics. All right? They would not have originated in Scandinavia or in Siberia or something like that. The males would have had great canine teeth, that is, large, relatively large canine teeth, as formidable weapons. They were probably fruit-eating, living in the tropics. Okay, so this is sort of broadly ape-like, just as the example that we came up with, that I guided you into coming up with this evening. So Darwin then goes on, humans are the most dominant animals that have ever appeared on the earth. How did this come about? How did we get to be so populous and so much, in our own minds at least, running things and in control? People brought up domestication and agriculture and things like that, but certainly having a massive impact already, obviously recognized in the 19th century on the environment around the world. So Darwin says this is due to changes in development in 3 areas that were particularly significant. All of these are not differences in kind between us and other animals, but they're differences in degree, or we have these things much more than others. So the 3 areas, the 3 factors are, first, intellectual faculties. Okay? So observation, memory, imagination, curiosity, reasoning, okay? All these sorts of abilities of the mind. Articulate language, okay, the kind of language that all human languages have, are the sort of key feature in advances in the brain and in cognition and so forth. So language is important with these other things. And that this then leads, and as, by the way, as I go through this whole model, these are all Darwin's ideas. I'm not telling you that these things turn out to all be true, what he said. I'm just giving you his outline of what we might expect. Once you have articulate language and these intellectual faculties developed, this leads to the invention of weapons and tools and traps, which we use for defense or for predation or for subsistence, technology and the use of tools. It also leads to the development of rafts and canoes and ability to travel over water in one way or another. Fire making, the controlled, not just using fire, which may occur naturally in various circumstances, but actually being able to make fire on demand and to use it in various ways. And in fact, Darwin says that being able to make fire and use it in various ways is only language is more important in human evolution in terms of changes than fire is and controlled use of fire. All right, so the first area is intellectual faculties. The second is in social habits, all right, behavior. And he discusses, along with behavior, moral faculties, social habits. So a moral sense is built up, and it's built on the social instincts and life living in groups. And that this living in groups and the social instincts leads to the golden rule, he says explicitly, which is the foundation of morality in cultures around the world as far as Darwin is concerned. So that's 2 areas. And then the third area is the body, the structure, the anatomy of the body. So what are the important things that happen there? He cites, first, being able to throw things hard and accurately. All right? This is a characteristic. All right? You will never find a chimpanzee that can pitch, okay, for the St. Louis Cardinals. Because they don't throw. Well, actually, I should take that back. But they're not particularly accurate or hard throwers in general. Using the hand and the arm and the trunk and muscles, there's a lot of things that go into being able to throw things. Even chipping crude stone tools needs what Darwin calls a perfect hand. I wouldn't say our hands are perfect, but certainly the structures are much better for doing that than in chimpanzees, for instance. And the third area in the bodily structure is bipedalism, bipedal posture, and walking in the way that we do. Okay, so these are the areas he says are important. What's the sequence? Now, the sequence, he had no direct data, but he sort of had to, this is speculative, and he says it's speculative, it's just a suggestion for the order in which these things might have happened. So he says some ancient primates started spending less time in the trees, more time on the ground, for whatever reason. It might have been to gather food, to get foods that weren't available up in trees. It might have been due to changes in the environment, less trees around. They had to come down on the ground. They were forced to. He doesn't know why. But if primates, almost all monkeys and apes, spend much, if not all of their time up in trees for food, for sleeping, all kinds of things, protection from predators. if you come down to the ground and you're an arboreal primate, you come down and start spending more time on the ground, there's two ways you can go. You can either become more quadrupedal, that is walking around on all fours, as baboons and monkeys like that have become, or you can become bipedal, and only humans have become bipedal among creatures that have done that. So for creatures that come down to the ground, the hands and the arms are not going to be really any good at making tools or at throwing things, while they're also being used for locomotion and supporting their weight, or while they're well adapted for climbing. So using tools and making tools, as far as Darwin's concerned, selected for having these capability of finely adjusted hands and fingers that allow you to touch and feel and manipulate and do various precise and detailed kinds of work. And you can't develop that if you're walking around on your knuckles the way apes do most of the time. But if you're upright and standing and you have your hands free, now you have the potential at least to do some of these other things, and you can start having selection for these other kinds of behaviors. Tool use and making, once you start to have this and you have these hands that are more adjusted for that, that leads to more and more bipedalism, and that leads to selection for changes in the feet so that they can support weight, so you lose the grasping hands and feet because they're now being used to support all the weight of the body all the time in a more productive manner. Okay. So, bipeds standing up on 2 feet have advantages because they're able, well, okay, I already said that about the toes, sorry. So thus, over time, you have species, or several species, that are becoming more and more erect, more and more bipedal, because this allows them to defend themselves by throwing rocks at predators, for instance, or throwing sticks at them, or clubs, or to attack their prey and gather food. It may be on the predation side, it may be on the protecting themselves from predators, but being able to use objects and successfully with the hands while you're standing up is more and more advantageous to these guys. Let's see. Okay, some other changes that are necessary as our ancestors became more erect. The hands and foot functioning become, along with the hands and feet changing, which I just mentioned. You have changes like, for instance, in the pelvis, where the structure of the bones becomes different and is recognizable in terms of the breadth of the pelvis and the positions where the muscles attach that run down to the legs and that are involved in locomotion and moving our legs from side forward and backwards and keeping our balance from side to side so we don't fall over when we walk. If you're bipedal and your weight's being supported on 2 feet, that's fine. That can be a stable position if you're just standing here. But if you're walking and you're moving and you're having one foot on the ground at a time and you pick up the other foot, well, now it's a little bit more unsteady to be standing here like this, relatively. And so it's in order for us to maintain our balance when we walk, there have been a lot of changes in the muscles in our hips that attach to the leg to move our body subtly back and forth over that point. And those changes can be seen in the shape and proportions of the bones in the hip in us compared to apes, and also in fossils when they started to be found. There are also differences in the spine and in the position of our head. Obviously, it's sitting on top of our body rather than out in front of it. So there's all kinds of skeletal changes that go along with these things. And then Darwin says there was feedback. He doesn't use the word feedback, but you can interpret it as that, between having free arms and hands and the erect posture. They're both cause and effect of each other. So each one sort of reinforces the other. You have more standing erect allows better use of the hands, which can select for more standing erect, which allows for more. Okay, so you can go back and forth in these things. And these things lead then indirectly to other sorts of changes. So that, he says, in males especially, the jaws and teeth, the size of the jaws and teeth, can be reduced because instead of using their canines for fighting with each other or for fighting off predators or protecting themselves from lions or whatever, they're using rocks and stones and sticks, and they can pick something up and throw it at them, and you're much better off if the predator is coming at you and it's 10 yards away and you can hit it in the face from 10 yards away. It's much better off than if it's 1 foot away and you're trying to fight it off. So the jaws and teeth can be reduced as a result of that. The skull becomes more like that of modern humans and like young apes. That is, the size of the muscles and the crest that muscles attach to is reduced. And so you get this sort of rounded globular skull like ours rather than the thing with big muscle attachments that you see in gorillas and so forth. The brain enlarges then at the same time because the mental faculties are gradually developed. He doesn't really say why or how. He's sort of waving his arms at this point. But, and then you have reduced amount of hair, which he calls nakedness of skin, which he suggests may have had to do with sexual selection rather than natural selection. And in fact, half the book, The Descent of Man, is about his ideas about sexual selection, which I'm not talking about at all here, but which was another one of his sort of original ideas which he introduced, which has been significant in the history of evolutionary studies since then. Okay, so this is sort of Darwin's model of how things might have tied together and how you might have ended up with a creature like us, starting with something that was much more ape-like. Since Darwin's time, of course, there's been 140 years of research on this subject. There have been, especially from the study of fossils and the discovery of fossils, there are now mountains of fossil evidence where he had nothing. And certainly today and in recent decades, and especially today, the increase in molecular research, which has allowed us to obtain all kinds of data that was not available to Darwin. And also there have been developments in functional anatomy and lots of other things. So how can we judge Darwin's model? How successful is it in terms of what we now actually know about human evolution from the fossil record? Some of the things that he suggested have been confirmed, and very strongly confirmed. So, for instance, the relationship to African apes and the idea that our lineage originated in Africa and that the fossil record of the oldest human ancestors and relatives would be found in Africa has all been dramatically confirmed in the last 75 years or so, especially. It didn't have to be that way, but it does turn out that the oldest fossil sites with, as you'll hear if you see the film tomorrow, are a couple million years older in Africa than they are else in the world with human ancestors in them. It doesn't mean that older sites won't be found somewhere else at some other time. It's still, of course, theoretically possible that somebody in Australia, for instance, where there weren't any humans before about 50,000 years ago, as far as we know now, but maybe it will turn out that humans originated in Australia. But since there's been so much work done and so many fossils found in other places, that Australia would be an extremely unlikely place to find a fossil deposit that was 5 million years old and had a human ancestor kind of thing in it. So to such an extent that if somebody claimed to have found such a thing, most of us in the field would immediately suspect that they were either crazy or a fraud. Right? Doesn't mean they are, but they're going to have awful good evidence to overturn the other. In other places, it could be more likely. So possibly in Asia, South Asia, Southeast Asia, there could be much older things that haven't been found yet, but they haven't been found yet. So what we know now is what we know now, and it certainly looks like Africa is the original home of the human lineage. The broad picture of the kinds of changes that Darwin talks about, the things that he mentions as significant factors, have also been pretty well confirmed. But what hasn't been, what's been superseded or passed, we've passed beyond in terms of the way people look at these pictures today, are a lot of the details. So it's clear now that Darwin was wrong in suggesting that all the different things that changed were all related to each other and all happened in one big feedback pattern, one thing to another, and all feeding back and all sort of happening at the same time. Not that it all happened fast, but all related to each other at once. That's a logical possibility. It certainly could have been true, but it turns out that it's not true. And we know it's not because you can find things like the oldest fossil evidence of bipedal locomotion. It's always good to have things where you have either bones or teeth involved. The reason that anthropologists, paleoanthropologists, those who study the past, the really ancient past, really tend to be interested in diet or locomotion because teeth and bones are relatively well preserved. It turns out that the oldest fossil evidence of bipedalism is at least 4 million years ago. I'm not sure what Tim's going to say it is tomorrow, but it's at least 4 million years old and could be 5 million years old, something like that. Could even be a little older. The oldest evidence of stone tool use, let's say, regular stone tool use, making things to the same pattern over and over. The oldest we have now is about 2.5 million years old. And I'm going to be awfully, I mean, it could be, and so are those the oldest stone tools that were made? Of course they're not. They're the oldest ones that we've found. Right? But stone is so durable and lasts so long and so well that I'm highly confident that they might be, 3 million years old, but you get back to 4 or 5 million, we would already have found them if people had been doing that then. So things didn't all happen at once. Some things happened before and some things happened later. They're still interconnected in various ways, but the details are a lot more complicated than Darwin made out. Second thing that Darwin didn't really propose and didn't really know about, but we do now, is there's not just one human lineage. You can't go from us and go back and trace and track and track and track, and you get to this common ancestor with chimps and gorillas and us, and there's just one lineage along the line. It turns out that there are multiple lineages in the past, many different fossil lineages, in fact, so that there have been times in the past when there were 2 or 3 or maybe 4 different human-type species, not all the same as each other, but all living at the same time, sometimes living at the same place, okay? So, and not all making a living in the same way, not having all the same kinds of adaptations. This is not something we're used to thinking about because today there's us and then there's chimpanzees and gorillas, and they're, pretty different from us in a lot of ways. What would it be like to be living in a world in which we had relatives who were a separate species from us, but were still quite similar to us in lots of features of their anatomy and their behavior? Okay, what if we had, if you think of, I'm trying to think of a good close example that people are familiar with, horses and donkeys. Okay, and there are differences between them, but they are really pretty similar in their adaptations in a lot of ways. What if there was we're the horses, and there was a donkey species of human that was still alive that also, it's hard to know from here what they would have been like. It's a different sort of world than we live in today. But we know for sure from the fossils that these things were back there. Some of these, almost all these lineages are extinct. I mean, they all are except for us. We're here. And we like to think of ourselves as really special because we're here. Well, they were pretty special too, and they're not here anymore. So, well, anyway, that's a sidelight. Okay. So we now know or can infer from the fossil record that there's not just one human way of living. There's not just one human adaptation. There are multiple human, in a sort of broad sense, ways of making a living. Some of those species in the past were around for hundreds of thousands or even several million years and then became extinct. Some of them had quite different, obviously, diets or ways of locomotion compared to us. So not everything is just like us or just like our ancestors. So when one is thinking about what makes us special and unique, these other guys were special and unique too. They weren't exactly like us. Anyway, it's more complicated than Darwin knew about. So what I'm going to do is, I'm almost done, which is good because I'm almost out of time. I'm just going to read, if I can go back, the last paragraph from The Descent of Man, as soon as the little gadget, the technology responds to me. Okay. So, Darwin says on a different page, whoops, here we go. This is the last paragraph in The Descent of Man. Man may be excused for feeling some pride at having risen, though not through his own exertions, to the very summit of the organic scale. I'm not sure I really like that progressive language, but that's good 19th century science. The fact of his having thus risen, instead of having been aboriginally placed there, may give him hope for a still higher destiny in the distant future. But we are not here concerned with hopes or fears, only with the truth as far as our reason permits us to discover it, and I have given the evidence to the best of my ability. We must, however, acknowledge, as it seems to me, that man, with all his noble qualities, with sympathy which feels for the most debased, with benevolence which extends not only to other men, but to the humblest living creatures, with his godlike intellect, he was really an optimist, with his godlike intellect which has penetrated into the movements and constitution of the solar system, with all these exalted powers, man still bears in his bodily frame the indelible stamp of his lowly origins. And now, for those who thought I was only going to show 3 slides tonight, I have the cartoon review of human evolution thanks to Gary Larson and the Far Side, the world's greatest scientific evolution illustrator, hey, look, no hands, an early stage of human evolution. So what's this? I asked for a hammer. A hammer, this is a crescent wrench. Well, maybe it's a hammer. Damn these stone tools. You have a small capacity for reason, some basic tool-making skills, and the use of a few simple words. Yep, that's you. No caption, but certainly the development of, and we know, as a matter of fact, from the evidence of things like bird bone flutes, or things that certainly look like flutes that have deliberately drilled holes in them at particular intervals that you can actually play, that people were making music of a recognizable sort at least 50,000 years ago, and who knows how much further back, because that sort of thing, bird bones don't fossilize very well in the first place, so who knows how many things made out of wood went away due to decay. Neanderthals, can't make fire, can't make spear, nah. Right? Living with creatures like ourselves. And of course, if we were teaching a class here, primitive spelling bees, cave, C-A-V-E, cave, oh sure, I'll probably get Australopithecus. Okay. So, for those of you who are interested, I have a few copies left of our newsletter, National Center for Science Education, and I also have some Darwin buttons. If anybody wants a Darwin button, you can come up and get one afterwards. They are absolutely free today only, and I'll be glad to try to answer any questions. Maybe some people want to leave. If anybody else has questions, thank you very much.